Okay, that's blah blah. Let's talk about types of reliability. So, there are various ways to approach estimates of reliability, because each of them has pros and cons. But all of them have the same goal, and that's to estimate our true score, so that T in our test, um, and be able to distinguish that from sources of measurement error. Now, each of these types of methods have various pros and cons. And I've got way more detail about how to calculate these in the notes and the textbook. So please do those. They will be helpful to you. But the four big types that we're going to talk about today are test retest, parallel forms, split half reliability, and internal consistency. And in this video, I'm going to go do a broad overview of each and make separate videos to give you kind of a more deep dive into the various testing types. All right, so let's start with test retest. This approach is fairly straightforward. You've probably used this in many of your experimental design classes where you essentially give the same test again. Now, this isn't just like standardized testing, this is anything. This can be a reaction time test, anything that records systematic human behavior. So, what we're doing here is evaluating the error associated with administering a test at two separate times. This is called time sampling error. And it's fairly straightforward. So, the idea is that any error on your test or any inconsistencies between your two test administrations of the same test are the result of time sampling or learning, depending on what you do. So in our class, we had that like pre-test of like what your pre-existing knowledge is. Well, at the end of this class, we're going to have that exact same test again, and it will do two things. One, it'll assess your learning, but it will also include some time sampling error, which will essentially be fatigue and response rates. But the basic idea is that you give the same test at time 1 as you do at time 2. The exact same test, not different variations of it, the exact same test. And then you calculate the correlation between those two. That's it. Easy does it. One test does it all. You don't have to make a new test, which is great. Super awesome and great. So that's test retest. A lot of these will have very nice straightforward names, which I love, because in other areas where we've got things like false positive, false negative, type 1 error, type 2 error, the names are not helpful. Here, the names are pretty helpful. All right, so the next one we have is parallel forms reliability. And so here we are evaluating the error associated with selecting a particular set of items. This is, in other words, item sampling error. And so what we do is we essentially develop a larger pool of items of varying difficulty across the domain, and then choose an equal distribution of items that are of various range of difficulty. You want to make sure to match difficulty so when you compare these two performances, you can see what's happening. And this is a way to make multiple versions of the same test. And then you give both forms very close in time, ideally at the same time. And then you calculate the correlation between those two administrations. And that should indicate what the errors are related to specific tests, like the test questions themselves. So differences between those test items will lead to error because you may get unlucky with a question on a test for you specifically. I know I've been unlucky in many cases where like I studied almost everything on a test, but I didn't have a great grasp of one specific concept, and I just hoped that that wasn't going to be tested. As someone who is chronically unlucky, guess what was tested? And so there I would have, a worse score as proportion to my basic knowledge because the question sampled was one I had less knowledge than my average knowledge, if that makes sense. But these have to be really close together, and they have to have matching difficulty. Okay, so next one of our big four is split half reliability. So what happens if we treat halves of one test as parallel forms? So instead of making two equally balanced tests, we just use the same test and just cut it in half. So each half of the test is a parallel form. This is a way to test for internal consistency in a very basic way. So the idea is that scores on one half of the test are correlated with scores on the other half of a test. And then you see if they're highly correlated. Now, how do you pick which half? We'll talk about that later, but you can do it a ton of different ways. You can do it first versus second. You could do random, or you could do every other one. There are tons of ways to do it, but essentially, you compute your score for the two halves, calculate whatever their test score is for each half, and then you see how they correlate. If you've done a good test, it should be highly correlated, the two halves. And if they're not, that's something to rethink. So that's split half reliability. It's one of many ways to measure internal consistency, but the other one, the most popular one, is Cronbach's alpha, which the idea here is that if items are measuring the same construct, they should elicit similar, if not identical, responses. And so this is called alpha. I actually have a note here about how Cronbach really didn't like having it called after him. But this test is just super, super popular. It's like the most popular out of all of the ones we're going to talk about. When people say alpha, this is what they're talking about. Because it's a really great measure for continuous data. Also, it's way easier than having to develop two forms. So, alpha is an estimate. But what we're doing is looking at how much of covariance exists between the items relative to the total variance. Lots of covariance in this class. So please watch that module on correlation and covariance, or book a time so we can work through it, because this is a really important concept that builds and builds, so don't put this off. So alpha is an estimate of reliability, just like a correlation is. I'm going to include some equations in the next slide. Will I? Yes, I will. So, I want to emphasize this. So, correlation is one estimate of reliability. Alpha is another. Alpha relies on covariation, not correlation. They're both estimating the same thing, but in different ways, based on different kinds of reliability study designs. And they both measure covariation, but in different ways. So correlation is a standardized covariation, while alpha is a slightly different standardization. They are different. Please don't mix them up, and be able to calculate them both. Cool. So that is wrapping up types of reliability. Hopefully this was helpful. I'm going to go into a deep dive into the various types. Again, make sure you don't miss out on those notes, because they cover a lot of detail and a lot of the math nitty-gritty, so that you guys don't have to keep rewatching the small chunks of video. Yeah. So I'll see you in a bit. Bye!